Recording.
Maths gears, brain, if you could work your gears, and okay, now I'm lost. Sunday morning, you open up your newspaper, you turn to the back, you look at the crosswords, you look at the Sudoku, you look at the chess puzzles, and you have a little bit of intellectual stimulation and you enjoy yourself while solving these puzzles. Maths can be the same. There's really fun things you can do in maths. One such thing is called a fallacy. Now, a mathematical fallacy is a proof that seems correct, but there's some subtle mistake along the way. The idea is that you follow the proof through to its end so that you can highlight what the disastrous consequences are of making a subtle mistake in a maths proof. And it can be quite funny to the mathematician. Now, there's a certain fallacy that's really been bugging me these past few days. Proof that pi is equal to 2 root 2. So the proof can't be right. Therefore, there must be a subtle mistake somewhere. So I've been working through this fallacy for a couple of days now, and I'm stuck. I can't find the answer. So I'm going to need your help to look through this fallacy and see if you can figure out where the mistake is. See if you can solve the puzzle. Okay, let me show you this proof. It's a definite integral from 0 to pi of x times f of sine x, where f of sine x is just any function of sine x. So we start with our integral, we make a substitution, the ratio of the changes is equal to -1. Move our bounds into the transformed space. The way we can look at doing that is we rearrange this to make the new variable the subject of the formula. And we say, what is the value of this new variable at our original bounds? So what is the value of x hat at x equals 0? It's pi. And what is the value of x hat at x equals pi? It's 0. So we have our new bound. So our transformed integral will have a negative dx at the end because of the changed ratio. And our new bounds will be pi where 0 previously was and 0 where pi previously was. So our new integral becomes the integral from pi to 0 of, now we're substituting in our substitution where our x was, and we end up with pi minus x hat over here, times a function of sine of our substituted variable, and we sub in our negative dx there as well. And we can take this -1, and we can swap the bounds of the integral, swap the sign of the whole integral. So we end up with the integral from 0 to pi of pi minus x times f of sine of pi minus x dx. And sine of pi minus x is the same as sine of x. And our integral then becomes the integral from 0 to pi of pi minus x times f of sine of x. And now we're going to consider a special case of this function, f of sine x. So we're going to consider the function f of u equals u times the inverse of sine of u. And what happens then when we put sine x into the function in place of u is that we get sine of x times the inverse of sine of x. And the inverse of sine of x is just x. So we're going to plug that in for f of sine x in our original integral to end up with the integral from 0 to pi of x squared sine x. And that's on our left-hand side. Now what we have on our right-hand side is our transformed integral, which we found to be the integral from 0 to pi of pi minus x times f of sine x, and f of sine x, like we found for this integral on the left-hand side, is x sine x. So we plug in x sine x here as well. And we can actually simplify this a little bit, because if we split this integral up, we end up with an x squared sine x, which is the same as that integral on that side. So our relation then becomes 2 times the integral from 0 to pi of x squared sine x dx is equal to pi times the integral from 0 to pi of x sine x dx. So all we need to do now is solve these integrals. And then isolate pi. And once we've done that, we find that the left-hand side becomes 2 times pi squared minus 4, and the right-hand side becomes pi times pi, where pi squared minus 4 is the value of this integral, and pi is the solution to that integral. We rearrange for pi squared, which gives us pi squared equals 8. Therefore, pi is the square root of 8, which is 2 root 2. And that just doesn't make sense, because we know that this isn't the value for pi. But I've been looking at this equation for multiple days now. I've looked at all the steps along the way, and man, I just can't figure out what's wrong with it. So either one of two things. Either pi actually equals 2 root 2, and all of our engineering and maths that we've done throughout history is wrong, or there's a mistake somewhere in this proof. Maybe you can find the mistake and prove to me that all of maths isn't wrong, and I can move on with a sound mind.